Okay, moving on, we are learning how to do some constructions for Unit 2, and all the constructions you're responsible for are in this lesson today. So you can refer back to it, you can watch it the night before the test, 2 nights before the test to review, so you're aware of the constructions. So the first construction we're going to do is related to parallel lines. So it says, given a point outside a line, that's this point right here, construct the parallel to the given line. So we need to draw a parallel to this line right here. Here's the given line through this given point. So here's a given point, here's a given line. We need to construct the parallel going through that. Remember, you can't use your ruler and line it up perfectly. It may not work anyway. It may not be the right thickness. Instead, you're going to have to do this one choice. There's lots of a variety, but I'm going to show you how to do this based on corresponding angles. So if corresponding angles are congruent, then we know the two lines are parallel to each other. So I'm going to try to draw or construct corresponding angles that are congruent with each other. So step number 1 is to grab your ruler. So this is my ruler today. And you are going to draw a transversal going through the point that intersects to the line. So your transversal needs to go through the point and intersect the line. Okay, then you're going to take your compass and you are going to make a corresponding angle. So here you have to put your compass so that the tip is right where the transversal and the given line intersect each other. And I have to make an arc that goes through the transversal and through the given line. So I'm making part of a circle there, right? It goes through the transversal and through the given line. And then I'm going to move my compass without changing that width. Notice I did not change the width here between my pencil and the tip of the compass. I have to make that same sized arc, again going through the transversal and then just going down as far as we think we need to, so that when I draw the line eventually it's going to intersect this arc. Now, if your second arc up here didn't intersect with the transversal, you're going to have to grab your ruler and line it up and extend that transversal, right? So you have to extend it up here in order to make sure that you're intersecting your transversal. Mine was okay, but if yours isn't, you've got to extend your transversal. Everything, the most important part about your constructions is having an intersection. Okay, when we're done with this, you have to move your compass. It's probably good to put your compass point, the pointy part, right here where the arc meets the transversal on my original arc right here. And I'm going to manipulate my compass until I can measure this relationship or how wide this angle is opening up, right? So I want to find out how wide it is from this side to this point over here on the given line. And if I replicate that, so I'm going to go up here to where my arc intersects my transversal, just as it was here, and I'm going to make that same length, right, that same, how far is that angle opening, oops, so right there, sorry I messed that up a little bit, I changed mine, so I go up here, I can see it's the same. So again, now I have my point of intersection. So I have this point of intersection. I have my original point I started with. I take my ruler and I'm going to, I'm going to manipulate it. This is going to be hard for me to get it just right. But you should take your ruler and just draw this line with your ruler. And when you line it up, this line should be parallel to your original given line. Okay, so you take your ruler, you line up those two things. It's very hard for me to get it just perfect, so I can't do it very well. But you should have better luck. You line those up. Again, it's a little off. And you connect it, and there's your parallel lines. So what I would do now is I would pause, and I would try it on the second one here. Or instead of pausing, rewind if you need to, watch this demonstration and try it on your own over here. Again, how are we making these parallel lines? We're doing it because this is a corresponding angle, Right here is my letter F, right here. So corresponding angles are congruent, so therefore these two lines must be parallel to each other. So pause now and try the second one. Okay, moving on. So to review, we are going to do the perpendicular bisector for a quick review. So I should have encouraged you to go ahead and continue on with number 3, because you should be able to do number 3 on your own. That was on the test, basically. So if you forget how to do a perpendicular bisector, what do? Well, you put your compass point on the end point of the given segment. You open your compass wider than halfway. You do your little circle, semicircle, or scoop, or half, not even half a circle, doesn't even have to be a semicircle. Just has to be far enough so that you think it's going to intersect. You go to the other side, you do the same distance, so this distance is the same as this distance, which means when you line up your ruler, you're going to make sure you connect this intersection with this intersection. And when you do that, so I'm going to use my board ruler so you can't see it. When you do that, you've then created a perpendicular bisector. So this segment is the same length as this segment, and this red line intersects the given line at 90 degrees. Okay, now we're going to learn 2 different instructions that are related to perpendiculars. So the first construction is to take or to make a perpendicular through a point given on a line. So this doesn't end, it's a line, it's not a line segment. So it says, given a point on a line, construct the perpendicular. So we're going to have a perpendicular going through this line. We must see construction marks. You cannot line up your ruler, get that corner, and just copy it. Okay, that's like a cheat method, and we're not going to give you credit for that. So we must see marks. So what do you need to do? Well, you put your compass over here on the given point, and you just open your compass so that you can make a mark on each side of the given point. Why are we doing that? Well, we're just making it equidistant. So now we know this is the midpoint of this segment right here. Right? So this is the midpoint of this segment. These 2 lengths right here are the same. Okay, but I need to construct a perpendicular. Well, I just created this segment right here. So now I can put my compass out here on the end point of the segment I created. I need to open my compass a little bit more because it has to be open more than half. I'm going to create that little arc. And I'm going to do it again on the other side. And then I'm going to take my ruler, which you can't see, and I'm going to connect these 2 points of intersection. Right? So I connect these 2 points of intersection, and therefore it should be going through this point, and this point. So I have a perpendicular to the given line through the given point. So this is my 90-degree angle. This line goes on forever and ever. However, I did manage to go through that given point. So that was through a point on the line. Okay, the next one we're going to do with the perpendicular. So we've done a perpendicular bisector, a perpendicular through a point on the line. Now we're going to do a perpendicular through a point not on the line. So this is very similar to what we did above. So what do we do? How do we do it? Okay, so you take your compass. This time you start with your compass on the given point. I guess we've always done that. We've started with our compass on the given point. Up here we started with our compass on the given point to make these 2 marks first. Down here we're starting with our compass on the given point, and we are going to open our compass wide enough so that we can intersect the given line on each side of the point. Right, so there's an intersection to the right of the point, there's an intersection to the left of the point. So what we've done, if we took, right, we know that these are equidistant, so essentially we made an isosceles triangle right here. Okay, so now, what do? Well, we're back to this perpendicular bisector construction. So we are constantly doing the perpendicular bisector construction. Here, once we got those 2 endpoints of the segment, we now did the perpendicular bisector. Here we have two endpoints of the segment, so what are we going to do? We're going to move our compass over, and I'm going to open it to make sure it's beyond halfway, and I'm just going to do my little scoop on top and on bottom. I'm going to move it over to this side, put my compass edge there. I'm going to do my little scoop on top and on bottom. I'm going to take my ruler and all three of these intersections, so the given point, this intersection, and this intersection should all line up. Get your ruler out, line those up. If you can't see, that's what I'm doing. And then here is a perpendicular going through the given point that was not on the given line. So step number one this time was to put your compass here and start with that scoop down here to intersect on both sides around this direction. Okay? So again, you can always stop, rewind, try again. But so far we have our parallel, our perpendicular through point on the line, our perpendicular through point not on the line. So let's move on. Next. The next thing we're going to do is a construction of a regular triangle. A regular triangle. So what does regular mean? We haven't talked about that yet in geometry classes, or maybe some teachers have, but I have not, and I know everyone has not. So regular we're going to talk about a lot more in our next lesson, and we're going to learn more about regular polygons. But a regular polygon, just to summarize, it's a polygon that is both equiangular and equilateral. So what does equiangular mean? It means all angles are equal, and what does equilateral mean? It means all sides are equal. So if we're going to make a regular triangle, we're basically making an equilateral triangle, or we're making an equiangular triangle. Okay, if I don't give you anything to do that, well, you can just start with any sized segment that you want. I wouldn't make it too big because you don't want your regular triangle to be that big. So start with any size segment. So here I started with this size segment. I have my end points. So what do? I just take my compass, go around, and I just measure the width of that, right? So there it is. That's how wide that segment is. Every side of the triangle needs to be that length. So what can I do? Well, I can treat it like it's a circle, and I can just make this arc up here in the air from one end point. I can go over to my other end point, spin my compass around, make the other arc. So I just did it. This is a radius of a circle. This is a radius of a circle. So that means this is equidistant, this is equidistant. Well, I labeled it off of this distance. So if I take my ruler, again, which you can't see, and if I line it up, let's see, I'm having a hard time lining it up. There we go, we line it up there and there, we line it up here and here. And that's my equilateral triangle. All three of these sides are the same length, and all three of these angles have the same measure. And specifically, a regular triangle has what? Well, these should all be 60-degree angles, right? If I created a regular triangle, then I created an equiangular triangle. Well, we know the sum of these three angles is 180 degrees. So if there's three angles, that means each angle has to be 60 degrees. Now, do we know the length of the side? No, you have to get a ruler and measure the side. But we do know that all three sides are the same length. Okay, our final one is a regular hexagon. So a regular hexagon means all the sides need to be the same length and all of the angles need to be the same going around the outside edge, okay, on the interior of the polygon now. So what do you do for a regular hexagon? Well, for a regular hexagon, the first thing we're going to do is we're going to start with a circle. Okay, so if I start with a circle, I'm just going to draw whatever size circle I want. I did it kind of small, so I have this space in here. Now, what you guys, I should have told you, given you a heads up, mine gives me that cross right there, so I know what my center is. You guys need to identify what your center is. Okay, maybe start with a dot or go back and find that little pointy part in your paper, and that's your center of your circle. Then you can, actually maybe you don't really need that. You can just start anywhere you want to on your circle. You can put your point there. And you're just going to make scoops everywhere around the circle like this. So I started with any point on the outside edge. I put a little scoop there that went through both parts of the circumference of the circle, the outside edge. Now I'm going to move my compass over, make my pointy part go in that intersection where the arc meets the circumference of the circle, and I'm going to make another arc going around. And I'm going to keep doing it. So here's another one. I always have to make sure it intersects at 2 spots on the circumference. So 1, 2, and then actually you can stop here, but let's just make a pretty picture anyway. We make the flower, right? If we continue on, we make the flower, we go to this last one, we make the flower, and there we have it. Oops, I forgot to continue, silly me. So now what does that mean? Well, if you take each of these points out here on the circumference of the circle and you use your ruler and you connect them, connect, connect, how many sides did that make? Well, it's 1, 2, 3, 4, 5, 6. So all of these sides are the same length, and all of these angles have the same measure. So this is a regular hexagon. Now the question might be why? Why does that work? And you know what? I'm going to leave that. I'm going to leave that to discuss, for you and your teacher to discuss in class. They'll probably discuss it when you do the regular polygon lesson. So this is how you do a regular hexagon. This is how you do a regular triangle. Why does it work? Why did this work? What did I really do here? The rest of these constructions are for you to practice. So go back and practice a perpendicular to line L at point P. Practice making a perpendicular to line L through point S. Here's some extensions. Can you construct an isosceles right triangle? Okay, we need a right angle, it needs to be isosceles. Think about it. These are application problems. These are the extensions we're going to put on assessments. Right? We're just not going to have you do one of these. We're going to make you extend and apply it somehow. Can you make the complement of angle ABC? What does that mean, complement? Right? Can you construct a 30-degree angle? So go ahead and think about it. Try these. And then there will be a different video with those constructions for you to watch, but I want you to try them on your own first. Good luck. We're all here to help you, so please ask questions if you're confused. Bye.